Hi everybody, this is Bharat, Assistant Professor, Department of Electrical and Electronic Engineering, SNS College of Technology, Coimbatore. We have been seeing the lecture series for the course Measurement and Instrumentation Engineering. Today, we are going to discuss the next topic of presentation. Last class, we saw about what do you mean by a sensor and a transducer. So this video is going to be about the measurement of non-electrical quantities. That this topic we are going to see is LVDT. Come, get let into the video. What is LVDT? LVDT is a linear variable differential transformer. So what is this linear variable differential transformer? Or sometimes it is also called as linear variable differential transducer. Okay, so we all know what is the definition of a transducer. Transducer is a device which converts one form of energy into another form. Similarly, this LVDT is also a device which converts one form of energy into another form. What is the form of conversion? Come, let's get into this. So passive induced inductive transducer, no external power from the core sensing. So precision positioning. So position of this is no, you can change mechanical to electrical conversion, displacement to AC voltage signal. So that is the main advantage of LVDT. So it is a measuring device which can convert the mechanical to electrical quantity or electrical to mechanical quantity. That is called as a linear variable differential transformer. So what is the construction of LVDT? When you see these diagrams, a simple circuit which consists of a primary coil which is given to an electrical supply. So secondary coil, two secondary coils which is S1 and S2. In between the primary coil and the secondary coil, you have a core. You can see at the center. So the primary coil is provided with the AC excitation and secondary coils are there and the core will be moving. So the electrical is converted to mechanical form. So that is the transducers phenomena of converting one form of energy into another. So this is called as a cylindrical former, primary and two secondary coils. So movable ferromagnetic core, the core is made up of ferromagnetic material and they are connected, the two S1 and S2 are connected in series opposition connection. So what is the working principle of an LVDT? So when I give the supply is given to the primary of the coil, so the core movement changes mutual inductance. So the output, when you just, the movement of the core makes the mutual inductance. The core, when we have, will make the core to move. Based on the movement, there will be a change in the inductance in the secondary coil S1 and secondary coil S2. When you take the difference between the voltage across the secondary coil 1 and secondary coil 2, you will get the output. So when the core is at the center point, there is no output. When the core is moved linearly between S1 and S2, then you get the output. So that is a linear output. That is a phase change. It indicates the direction of movement. So this converts the electrical to mechanical or mechanical to electrical forms. So signal conditioning. So it is a very simple principle behind the concept of LVDT. Hope you understood the signal. The signal conditioning is done in this LVDT with the help of a small processing. That the signal processing is done by demodulation process, which is AC to DC conversion, amplification, which increases the signal level, and filtering with the effect of removing the noise signals from this, and the output is measured. And when you take about the characteristics and performance of LVDT, LVDT is a very simple but a very important device used in many industrial applications. Even today, wherever you need to have the motion and associated with electrical data, there they use LVDT. So it is a linear range, operating range of measurement. It has a high sensitivity, high resolution, repeatability and accuracy is very good. Frequency is also good. Output and as a displacement is shown on the graph. You could see the output. So what are the various advantages of using an LVDT? So LVDT does not have any friction. Does not have any closed contact. So there is a coil, there is another coil. In between the two coils, there is a core. So no fixed contact is there. So high resolution, high accuracy is there. Infinite resolution is there. Long life and durability is there. Rugged construction, immunity, that is EMI and ESD operations. Okay. Next is what is the various applications of LVDT? CSC machine positioning feedback, aerospace flight control, value positioning, structural monitoring, automotive systems, and precision metrology. So these are the various applications of LVDT. What are the various limitations and comparisons? Limited measurement range, magnetic field sensitivity, AC excitation required, and when you come to the conclusion, so a small recap, what we have seen is the LVDT, so linear variable differential transformer or a transducer, which can convert one form of energy into another. Here we are converting with the help of a primary coil and secondary coils. In between the primary coil and secondary coil, there is a core. The core is made to move. Based on the movement, there will be a change in flux in the secondary coils. When we measure the difference between a mutually induced flux in the primary and the secondary, we get the electrical output signal. So excellent precision with this displacement measurement, widely used industrial applications, signal conditioning essential for performance. There are various key advantages and future trends in the case of LVDT. So thank you. Let's meet in the next video.